they have to understand that shopping and downloading without parents' permission can make them in risk. And also adequate training is important either in the family or both in the family and in the academic institution. However, we have some strong limitations, and we agree, as because this is the starting of a big research. And first of all, for the interview, we only used snowball sampling. So as we are three authors, we only collected interview data from our first or secondary relatives, or the second one is city dwellers. All the children we went there, and all the 17 schools were basically the city or near the city. So we couldn't go to the remote places, and eventually we'll go. Actually, number three, children out of the school, and included. There are many children in Bangladesh who do not go to the school or who has left study. We couldn't reach to them, is because our study is based on 17 school children. So the children who do not go to school or left school, we couldn't reach to them. Children from privileged society, most of them from either from middle class or lower middle class, we couldn't go to the very poor family children from very poor family. And also boarding for children, in that term, that we could only meet to the children on their tiffin period. So that was around 20 to 25 minutes. We visited many days to those children, but they were sometimes fast enough. They were very quick. They didn't want to lose their time in their tiffin period. So sometimes their answer could be actually not the accurate one. These were our limitations. And these are the future research plan of us to diversify the children. We have to go to more children or more diversified families, and we need to discuss with other stakeholders like the parents, the educators, the game developers also. And we are on the way of designing a machine learning model for prediction. So to predict after the information of children, we want to predict that whether this children has the threat of being abused or harassed. And finally, we want to make a cognitive and conceptual model for which will ensure actually, or which will ensure the privacy and security of these children. And thank you. I tried to be within the time, sir, but probably 1 or 2 minutes is extended. So thank you very much for giving me the chance. And please, if you have any questions.
Okay, Rumal, thanks for the presentation. So the question you have prepared for this research, how do you get them?
Sir, we actually, the questions were developed for the survey from the interview. As I said, we initially went to 48 children for interviewing, and we actually made around 40 to 45 minutes of with them.
Whatever you have asked them based on some standard guidelines, huh? So
yes,
that's why I'm
sir.
asking,
Yes,
how you have prepared them?
From our literature review, sir. We have studied the same types of things, or the psychiatrists, the people who are working with the children.
No, actually, there is already policy guide available from UNICEF for children and digital connectivity.
Yes, sir. And
so
also,
sir, there is are there standard was there?
Yes, sir. Yes, sir. Standard were maintained, and also there is a guideline, sir. COPPA. I think you know, sir, about COPPA, the American standard. We actually followed that one, so that that is not being asked some questions which they will not like to answer, sir.
Okay, so is there any future plan for it?
Yes, sir. As we have, this is the beginning of the broad work, sir. Here is our future plan. We are going to, sir, discuss with the more stakeholders. For example, sir, parents are the most important stakeholder for the children.
Okay, got it. Yes, thank you. Any other question?
Mr. Rubel,
yes, sir.
You have made a survey,
yes,
and based on the results, you have identified the problems and then put your suggestions.
Yes, sir.
But is there any mathematical or technical aspect that you have utilized to get this solution? I didn't find any correlation, because the suggestions you have made are pretty obvious. Even
Yes,
without making this survey, we can put these suggestions. So can you
yes.
correlate? How did you come to these suggestions?
Sir, thank you, sir, for your question. Sir, this problem is a social science problem, but the solution should come from the computer science aspect. So as a computer science student, I wanted to find, or we wanted to find the actual, yes, these were obvious, but we wanted to find whether this is also the same for the perspective of Bangladesh, I mean, northeastern Bangladesh. For example, sir, in the Western world, the children are being treated in one way, but in our countries, the children are within the family, the children are being treated in a different. So our target is to make a machine learning model, sir, prediction model, which you can say in our third future plan, so that we can utilize this data for making our machine learning model for the prediction, so that we can get, if we have information like age or family status or something, or 4 or 5 things of the children, we can say yes or no, this child has the is being will be has the chance of being abused or harassed. So far up to this work, we do not have any mathematical equations or done, but in the future, sir, we'll do machine learning from using this data, sir.
Okay.
Thank you, sir.
I have one question. You
Yes,
have
ma'am.
presented an app regarding game,
Yes,
like that. So you have developed this app. So when
yes.
when you visit to those children, you have given them this app to download this app and then play.
No, ma'am. No, ma'am. Actually, we have managed 8 members of our team who are actually university students. We have paid them a lump sum amount. So we trained them for few days, for every day around hour or two, and we 8 of these students with our sometimes 2 of our authors or 3 of our authors went to visit them. All the devices, we actually took devices with us, like around 8 to 10 devices. Always we went to the school, that children did not need any to download anything. They were just given the device so that they can play the games.
Okay.
Thank you, ma'am. Thank you, sir, for your
So, ma'am, we
kindness.
can call the next presenter.
Yes, please.
So our next paper is a scalable URL-based phishing website detection system using machine learning technique. Paper ID 8020. Anyone present? If there is none, the next paper is accident detection and prevention for advanced driver assistance system. Paper ID 4155. Anyone present?
Yes, sir.
Anyone present for that paper?
Yes, sir.
No. So please continue.
Okay. Is my screen visible, sir? Hello.
Yes, it's visible.
Okay, so my paper presentation title is Accident Detection and Presentation for Advanced Driver Assistance System.
Mr. Sanjay, I request you to complete it by 8 minutes. So that is 5:23 now.
Okay, sir. Myself, Omkar Sangve. The paper will be presented by me. So, introduction of our model is, as we have seen that the accident is the main cause of the death in this world, as all the people are in hurry. They wanted to do the task in less time, so they fasten their cars and has happened. So how to prevent that? So we have came up with the idea. So we have developed a model, or we can say the physical system that will prevent or detect the accident, or if the accident has happened, then how to get the cure in less time. So we have developed a system for that that thing. This is how the system looks. We have used some hardware components. Uh, like there are the three major components of our system. That is the microprocessor, that we are using microprocessor of Atmega 328P, that is the Arduino, and then the GPS and the GSM. GPS in the sense for sensing the location where the accident has happened, and the GSM for GSM stands for Global System for Mobile Communication. That is for the communication between the police or the healthcare to the accident location or the car. So these are the components that we are using. We are using Joe in GPS Neo 6M, GSM 900A, MPU 6050 sensor as the accelerometer and the gyroscope sensor. This sensor contributes in the sensing of both the acceleration and the gyration. So it senses the input from the 6 axis, that is the acceleration from XYZ and the gyration from the XYZ. Based on that, we can conclude that the what is the tilt of the car and what is the acceleration of the car, based on mix and matching or the permutation and combination that we have done by experimenting. So we will come up with the conclusion that the accident is happened by sudden change in the acceleration or the what is the tilt of the car is. There are also flame sensors and the ultrasonic sensors for the prevention of the accident. Like sometimes the engine gets caught the fire. So in that case, this is also the kind of accident. So in this case, the system will be activated, and if someone is close to our car, so the ultrasonic sensors will do that work. So if the threshold will be 20 meters, then if some car is getting close to us by 20 meters, then the buzzer will buzzing, and the driver will get to know that some car is arriving. So main advantage, or we can say the main goal, is to achieve the accuracy of the system. So in the hilly areas or the we can say that if there is no network coverage, then how does the system works? So that's why we are using the new section, which connects up to the 20 satellites, and we have tested that its accuracy. It is very accurate, like up to 20 meters it can be accurate. We have tested it using 4 different locations nearby ourselves. So this is the block diagram of our system. Like when this MPU 6050, when the car ignition starts, this MPU 6050 and all the systems get turned on, then MPU 6050 continuously monitor the acceleration and the gyration of the car. And in the microprocessor, it will continuously get processed what is the tilt and the acceleration of the car. And based on the thresholds that we have said, if the accident is happened, then the location of the car is fetched by the GPS module, and the GSM module will send the message to the healthcare facility, police, and the registered mobile number. Also, there are some sensors like eye blink sensor, flame sensor, and ultrasonic sensor for the prevention of the accident. So these are some of the results that we can see. So in the right side, there is location, and then the left side, the message we have received, like a vehicle accident has been happened here, and you just have to click the Google Maps link, and you will get the location of the particular area. That's it from my side. Hello.
You are detecting accident based on accelerometer only.
No, sir. We are detecting accident based on the acceleration and the gyration both, because the MPU 6050 senses acceleration as well as the gyration of the 3 axes.
You are expecting that even if accident happens, a car crash, your system will be intact inside the car. Otherwise, it cannot sense and send information.
Actually, sir, we have tried to create the prototype of the systems, but we haven't tested it in the real car. But we will get to manage that. We will get manage that the system will be intact in the car, like the black box in the aeroplanes are made up of titanium. So if we could manage that, so we can remove that test.
Your objective is to detect accident or to caution the driver from happening accident. What is your objective?
Sir, as the paper title is prevention and the detection both.
Or both?
We are trying to
Okay.
prevent both and the detection. If accident has happened, then the cure will be available in less time.
So have you made any simulation and tested it? You have used, I have seen that the eye blinking or other sensing information. Have you tested that, implemented anywhere?
Yes, we have created the small we can say small model, and you are saying that the eye blink. So this is in the future scope. We are trying to detect the drowsiness of the driver. Like sometimes the driver feels drowsy, so there are chances that the accident will be happen. So to remove that case, we are trying to use the eye blink sensor.
Okay, from my end.
Did you compare your approach with any other existing approaches regarding accident detection?
There are the mini accident detection systems available right now in the market, like Tesla's car
So,
crash or the
Did you
Tata's.
Did you compare your prototype with any of these systems?
Yeah, the main advantage of our system is very cost effective.
Okay.
So that
So it's a suggestion from my side that it will be better if you put a comparative analysis, or if it's not possible, so a comparison table with the existing systems highlighting the advantages of your system.
okay, ma'am.
So, Mr. Singhal, do you think the uh, processing speed, processing power, or the memory available with that Arduino Uno is sufficient enough to run this whole algorithm in a real life system?
That's why sorry for the
Means the
audio
Arduino you are
interruption.
using, no?
Yes,
So
we
the
are using
processing power
Arduino
and the
Uno.
memory required, the memory available with the Arduino is very limited.
Yes.
So, do
So
you think that is applicable for a real life application? What you are proposing?
So as I said that we haven't tested in the real life car, we have just created the prototype. Uh, if we want to
No, if
use
that
it in the
prototype
real
is
car,
working, if that
yes, sir,
prototype is
it is
working, it is
working.
applicable in real life with that
Yes,
particular, with this small processing speed and very basic memory.
we can increase the memory by using the Raspberry Pi or the other microprocessors that are available in the markets. That is not the issue.
So that time the system architecture will change, na?
We just have to deal with the input and the output of the with the microprocessor. Other things shall remain same.
Okay, thank you so much.
Okay, sir. Thank
So,
you.
ma'am, can we call our next participant?
Yes.
So, the next one is lever safety analysis using object recognition and deep learning. Paper ID 4600. Anyone?
Yes, sir.
Please.
Okay. Hello, can everybody listen to me? Okay. good morning to the panel. Good evening to the panel. So our project is labor safety analysis using object detection and deep learning. So what basically is our problem statement is that so in many industry sector, people usually don't use their safety gears, which causes many damages to the company and the labors itself. So we are going to try to combat this using object recognition and deep learning. So our objectives for this project is to identify the peoples in the frame, because they are the people who are getting affected, and we are going to recognize the objects, the safety gas here, like mask, helmet, and vest, so that they are wearing the safety equipments or not, and we are going to classify them, classify each person if they're wearing it or not.
So the methodology involved in this project, we described that schema diagram. So flowchart here, we are going with the YOLO V8 model, which is the latest model which has been released January 2023, and there we have trained the more optimized and the pre-processed data sets involved of the detection safety gears, and along the training we have deployed it in the real world scenario, and is capable of detecting whether the worker is wearing the safety gear detection or not. So that is the model which we have trained. So the algorithms input which needs to be analyzed, and the output is accurately detecting all the safety gears from the worker. So here it involves when we take a video for an example. So we are iterating through each frames, and in each frames we are first cropping the workers involved in frames, and in each workers we are detecting the object involved, like the safety gears, whether they are present or not, and using our algorithms which I have come up with, we'll detect whether a person is completely equipped with the safety gear. If not, we'll give the respective alert signals. So here again, as this labor safety analysis involve surveillance, means it involves continued surveillance for like 24 hours or beyond. So that's why we have come up with 3 effective methods in order to come up with key frame extraction, where in each frame we'll be getting whether or not we need to provide some computation on that particular frame, whether there's a subsequent motion is detected in that frame. In that case, we are using the computation. Otherwise, doing the computation on each frame would be resource intensive. So in that case, we are coming up with key frame extraction. One of them is caching, where if we are storing all the bounding boxes dimensions within dictionary. So when we come up with the same bounding box dimension, we'll use the previous data rather than deploying our model on that. So thus reducing the resource. In case of periodic approach, we are trying to come up with this one. It's using the computation on an interval basis. For example, for each n number of frames, we'll be applying our computation model. So this is also in turn reduces the computation requirement.
So one more methodology is boundary subtraction. So what we do here is we find the boundary of any object in the frame. So how we find it is basically we take the input as a RGB colors image. So we converted it into gray, that's black and white. Then we see the intensity change. If there is a lot of intensity change, we make the borders of we outline the borders of that object. So using this, we can find out the object size. So if there is a change from one frame to another frame, that the size of the object will change. By this, we can predict that there is some change in the frame. So we have to use a model to detect if they're wearing the safety gear again or not.
So each methods have its own advantages and disadvantages. So when we go with the caching method, it is more effective when the frame is not having much of movements. For example, if a worker is not having too much of movements, then the dimension of the bounding box of the worker remains same. So it will be quite adequate that he'll be wearing the same safety gears again. So thus another computation is not. But the disadvantage is frequently moving workers. So in that case, we need to keep on applying our model. So that's why it's resource intensive. In case of boundary subtractor, it helps in reducing the reprocessing of frames. So in case if we detect significant movement in case of the frames, in that case only we are deploying our model. But it's not suitable in case of fast changing scenes due to high memory requirements. In case of periodic approaches, there might be good amount of chances that we might miss out some keyframes where the worker might remove his safety case or vice versa. So disadvantages, that's what it gets skipped. So that's why that's the disadvantage. The advantage is it helps in skipping of frames. And we have also used media pipe for this one because there might come a scenario where boarding safety care might be within the boarding box of a person, but he might not be wearing it in the right area. So that's why we have come up with media pipes where the coordinates, which is essential, where it maps up with the safety care. So we try to map it up, and using our algorithm, we'll check whether the particular safety care is mapping within the required area. If yes, then it's a green signal that he's wearing the right safety gear at the right place, and is good to go. Otherwise, we'll be providing alert signal. So that's why we have implemented it. So techniques to measure approach, like we are providing a time in case of execution of each method. So by that we'll analyze the approaches and how methods will be effective in scenario. So design implementation, next is the data sets. Next, so the data sets we are taken from Webflow, so it has a good amount of detection for persons and all the required safety cases. So that's why, and it has been pre-processed. So it has provided a good blend of all the gray measure and shear, all those provided. So thus it is more effective for training a model. The hardware, so CPU, GPU for effective computation, and RAM. The software you have used PyTorch, Python, CUDA for installation, providing frameworks. Sony IDE for deploying our model, and OpenCV stopping the frame-based operations. So these are the techniques. Pre-process and augmented data sets, which is already we have created, and we have done some changes on that one, and training using command line interfacing, then annotations and frame extraction. This is the performance of our model on the one data set. So it has provided more considerable their outputs. So it was successfully able to detect the desired outputs and more accurate results compared to the previous research papers which we have gone through. So these are the results. It is deployable on real life scenario, and when we run a video, it will be able to successfully detect whether wearing, and it will also detect which are the keyframe indicators and when it needs to be deployed.
So in this image, you can see we are using media pipe, and you can see the dots showcasing the head and shoulders and thighs. So we can get to know if the helmet is on the head and if it's on the dot. So we are recognizing that he's wearing the helmet in the right position. So this is periodic approach. You can see the number of frames. In this scenario, we have used 30 frames per second video, where we are predicting every half a second. So it's predicting in 15 frames. Then this is caching. So basically, if the person is in the same place in the image, in the video as the previous prediction time, so we'll use the same same results rather than using the model again and wasting the resources computation. Then this is the background subtractor. You can see here first we detected the person, and then we cropped the person. Then we found the contours. Contours are basically the outlines or the shape of the object. So we'll find the number of dots in this, and if the dots change, we'll store it in a memory. And if the next frame, if the dots change, then we'll know that there is a movement in the frame, and we need to apply the model again. So summary. So we could detect the workers who are wearing the safety vest and helmet and masks, and we applied 3 different approaches for keyframing. Then we measured, and we even used the media pipe, and we measured even the efficiency. Yes, sir. Okay, sir. Then future, we will try to optimize it more. It's taking, it's not almost, it is almost real time. It's not real time. So we can optimize this more. We can even improve it by merging all of these three methods and even implementing MediaPipe. And we can also, in future, we can even have some sensors built into the safety gear so that we can detect that if he's wearing the proper safety gears or not. So, and we have extracted few particular features like only helmet, vest, and mask. We can improve it by using boots and gloves and other safety equipments. And this is not just limited to construction site. We can generalize this and we can apply it for even sewage treatment plants, chemical laboratories, and even in medical laboratories also. So these are the references we took. We gone through 8 page papers. And yeah, thank you. Any questions from the panel?
Okay, have you tested the other baseline models? Any model like Faster CNN or
So-
also have you tested it only one single database? I am sure that there would be multiple such databases available publicly. So have you make any comparative study?
So first, here we are using two models. So first model is the pre-trained model, which YOLO already has. It's trained in COCO database. So we are using this to detect the person. Then we use the train model, and no, we did not use a different data set. We used only one data set. So we can even, that is the future work. We can use more data sets and improve our model.
Gone through previously many data sets, sir, but this was the more optimized way of process and all the parameters. So thus it was trained using different scenarios of each images. So we thought this was more optimized when it comes to detecting safety case in different instances. And when it comes to model, YOLO V8 had best MVP scores when compared to rest of the YOLO models, and compared to the other RCN and all. This one is capable of computation case of faster FPS. So that's why we thought this was
that study is also required. No? When you claim anything, it should be supported by data that you have achieved.
Yes,
No, this is the YOLO model, YOLO V8 model, sir. So this YOLO V8 model is a standard model in the
That I
YOLO.
know.
Yes, sir.
I'm asking about comparative study with other models. That would have better.
Okay, sir. Okay. We will add.
Okay.
Any other questions?
Did you measure the accuracy?
We measure the model using the, you can see the confusion matrix.
Okay. Yes. Okay. So as Sad has also mentioned, so this is a small suggestion from my side also, that you it will be better if you compare this approach with the existing baselines or any other existing approaches, and to showcase the benefits of your approach, what are the advantages of your approach. So it will be better.
Okay, thank you. We will make sure that we add it in the next step. We'll add it. Thank you. Any other questions?
I think we can call the next presenter.
Okay, thank you. Thank you. Thank you.
Yes, we can call the next presenter. So the next paper is paper ID 766, currency recognition app for blind people. currency recognition app for blind people. Is there anyone to present this paper? Or we will move to the next one?
The last one, I think.
Yes. Paper ID 160. Endoscopic surgical operation and object detection using custom architecture models.
Yes, ma'am.
Okay. Please start.
Yes. Good evening, everyone. Our topic is endoscopic surgical operation and object detection using custom architecture models. Introduction. In the medical field nowadays, there's a wide use of micro cameras for real-time surgical experience, especially for surgeries in internal parts. For example, laparoscopic cholecystectomy. We have focused on multiple label classification using various neural network algorithms like convoluted neural network, ResNet 50, VGG 19, VGG 16, MobileNet V2, and YOLO V8 model. These algorithms are applied on the validation data set and the instrument, verb, target are displayed, and instrument information are also displayed on the video monitor. The evaluation metrics used is accuracy, precision, recall, F1 score, and Hamming loss for the comparative study of the algorithms. X-rays, CT scans, and MRIs can also be used reliably to detect and classify using the suggested procedure. Motivation. This idea has a great potential to enhance surgical procedures, improve patient outcomes and feedbacks, and advance the field of medicine. To leverage the power of artificial intelligence and computer vision in order to enhance surgical precision, improve planning and decision making, support training, and drive innovation in the field of minimally invasive surgery. Literature review, we've researched on many papers which used algorithms like YOLO V3, YOLO V5, EndoNet, etc., where the accuracy is affected by the recognition issues from the identical features of the medical instruments due to the limited analysis of surgical tools. Miscommunication between the AI model and manual work requires specific instructions. Real-time data is not being used due to time constraints, where issues like insufficient feature extractions and erroneous detections cause the overall system performance to degrade. The data set we have used is taken from the Collect Triplet Open Task Challenge, where the training data contained images extracted from 45 videos, and the validation data set contained bounding box dimensions. The XML annotations which contained the bounding box dimensions were converted to the text format in order to perform YOLO V8. The novelty of our model is YOLO V8 is used for multi-label classification of the medical images. The training data set is large so that the classification and the accuracy is not affected by the identicality. Real-time data is used, and the cholecystectomy recordings were annotated by 2 surgeons for perfection. The results we obtained is the table shows the comparative study of the various algorithms we have used, and the F1 score, recall, precision, exact match ratio or accuracy, Hamming loss is compared. These are the YOLO V8 model results, which shows the class. We have 7 classes here, like hook, scissors, clipper, specimen bag, grasper, etc. And these are the this is the graph obtained, which shows the loss, and which shows a decreasing graph, and then the metrics, which is precision, recall, which shows an increasing. Thus, concluding YOLO V8 has showed its best performance amongst the algorithms. In future, we would like to work on multiple organ detection and use 3D images for analysis, whereas in our project here, we have used 2D images. Thank you.
Madam, can you please go to the result slide? Yeah, before that, yes, yes, yes. Yes. Okay. So is there any question from the audience? Or Shobhik sir? Yes, sir.
Yes. What is the biggest challenge do you think that for classification of this type of case?
The biggest challenge was converting the images into into the required format of YOLO V8, and then annotation part, the bounding box dimensions. We actually found it difficult to obtain the Xmin, Ymin, Xmax, and Ymax, the bounding box dimensions required for the YOLO V8 model.
Okay, and then apart from YOLO or any other deep learning model, this problem some in literature has been addressed by manual selection of feature. Have you seen that? By manual selection of feature and conventional machine learning, this combination have also been used for this particular type of problem. So have you seen that or tested that case also? Or all you have tested on deep learning?
We have tested on deep learning only, sir.
Okay, okay.
So there is
So
no
I
other-
think, yeah, if there is no other question, we can conclude the session.
Yes, yes, yes.
Thank you.
Thank you all the participants. Yes. Thank you, Dr. Anisha and Dr. Basu. I think we can conclude the session.
Thank you.
Thank you, sir. Thank you for your time. Thank you.
Okay, we all may leave now.
Yes, yes. Okay. I am closing the session. Okay. Thank you, sir.